Hey guys, today we're reviewing operations with scientific notation. Okay, if I have 5 plus 7, I can think about this 7 as being a 5 and a 2, right? So technically, I could take 5 away from the 7 and add it to the 5 over here, and then I think of this as a 10 plus a 2 to give me 12. That's just one way of thinking about a number. Just like if I wanted to add 33 and 17, I could take 3 away over here and give it to the 17 over here and think of these as a 30 and a 20. Okay, this is just a strategy to kind of solve a problem in your head if you don't have paper or if it's not coming easily. So you can do the same thing with multiplication and division. If I have 22 times 5, I can divide the 22 by 2, multiply the 5 by 2, because these things are canceling each other out, and I get 11 times 10, which I know is 110. I could do that same thing when it's a big number and a small number, or even just two numbers in general. If I really don't like working with, I don't know, say 6 times 8, but I love working with 3s or with 12s, I could divide this by 4, or I love working with 2s, divide that by 4, multiply this by 4, I get 24 times 2, and I know that doubled is 48. You can do this however you want to make your life easier. Okay, it's about making your life easier. Okay, so let's review scientific notation, and then I'll get back into why I kind of went there. Okay, multiplying with scientific notation. You multiply the numbers that are rational, and then you multiply the powers. So 1.4 times 7.6, or 7 and 6/10 and 1 and 4/10, gives you 10 and 64 hundredths. Okay, 10 to the 3rd power times 10 to the 4th power, like we know when they have the same base and different exponents and they're being multiplied, we add the exponents and we get 7. We know this isn't in scientific notation because 1, let's review scientific notation. It has to be a base of 10, which it is, but 2, your product, the one factor has to be a number that is less than 10 and greater than or equal to 1. It cannot equal 10, and it cannot be anything less than 1. So this one is above 10, so we have to move the decimal point this way. So what am I actually doing here to move the decimal point that way? I'm making it a smaller number by dividing by 10. And over here, we said, what if we divide by the number, the other number has to be multiplied by that same number. So here I'm multiplying by 10, or 10 over 1. So when I divide by 10 over here, I get 1 and 64 thousandths, and in multiplying by 10 over here, I get 10 to the 8th power. Okay, go ahead and try this one, and I will be back in just a second to show you what I did. All right, friends, grab your red pen. Step 1, multiply them separate, integers or rational numbers with each other, and base of 10 and powers together. You get 13 and 12 hundredths times 10 to the 12th. We have to divide both sides by 10, or we divide this side by 10 and multiply this side by 10, which gives us 1 and 312 thousandths times 10 to the 13th power. Okay, so I showed you that first part. Try this one for me and I'll be back in just a second. All right, so the first part, you should be multiplying these two together and these two together. You get 4.5 times 10 to the 7th power. And if we want the product in scientific notation, that was the right answer. But you can also write it in standard form. Notice that in standard form, the 4 and the 5 are not both place value holders. The 4 is already there, and I'm using the 7. 1, 2, 3, 4, 5, 6, 7 places. The 5 is included. It's not 7 zeros. Okay, so be very aware of that. Okay, so for this one, I want you to write the product in scientific notation and standard form for me, and I will be back in just a second to show you what I did. Okay, 4 times 4 is 16 times 10 to the 6th power. So the first part is to write it as scientific notation. 1 6/10 times 10 to the 7th power, because again, you're dividing here just so that way you can multiply here. So you get 16,000 or 16 million. And here's why. Because you're moving it one place and then 6 additional places for your 7. Okay, let's chat about dividing. Same thing. Divide this one, and you get 25 hundredths. Divide this one, and -1 minus a -4 is a not. So that's like adding 4, so you get 10 to the 3rd power. Now, am I allowed to have this as scientific notation? Nope, it needs to be 2.5. So how do I get there? Multiply by 10 over here and divide by 10 over here. That gives me 2 5/10 times 10 to the 2nd power. Okay, so you've got to be careful. Whatever you do to this side, you do the opposite, the inverse to the other. All right, so another one. Here, I would take 4 4/10 divided by 2 2/10 and get 2. And then 6 minus a -3, that's a not, so it's like +3. Okay, why don't you try this one for me, and I will be back in just a second to show you what I did. All right, 9 divided by 3 is 3, and -3 minus 5 is -8, and I'm done. Okay, let's try another one. This is our last example, so go ahead and try it, and I'll be back in just a second to show you what I did. Okay, first step that we think is 1 1/2 divided by 3, and then 10 to the 4th divided by 10 to the 6th. So 4 minus 6, or 4 plus a -6, gives me a -2, and 1/2 divided by 3 is 1/2. So 0.5, written like this, we need to move that decimal point this way. So what we have here, we would have to multiply by 10 and divide this one by 10. So really this looks like this fraction, -2 minus 1. So we get 5 over here and -3 here. All right, so you should have 2 rules. We've got this one for multiplication, this one for division, and you should have 7 examples for me. Okay, and that's all I have for you today. See you next time.